Hey there, what's up guys? In this video we're having another look at derivatives, but this time it's using the power rule. So this is how the power rule works. If you have a function, perhaps a coefficient of a times x to the power of n, then the derivative of this function would be if you take the exponent n, multiplied it by the coefficient a, and then decrease that exponent by 1. So the derivative will look like this: n times ax to the power of n minus 1, where n and a is being multiplied together, the exponent and the coefficient, and also the exponent is decreased by 1. Alright, let's have a look at this in practice. Now for a first example, I'm going to give you the function f of x, which is equal to 3x to the power of 4. Where 3 is my coefficient and 4 is the exponent. The derivative of this function would be if I were to multiply that exponent with the coefficient, so 4 times 3 is 12, and then I would also have to decrease that exponent by 1, and 4 minus 1 is 3. So the derivative is 12x cubed, and that's it. That's your answer for the derivative. We can even have a look at a second example. Again, I'm giving you the function f of x, and that is 5x squared plus 10x to the power of 7. This function has two terms, but when you find the derivative, we take the same process. Remember, you want to take the exponent, multiply it in front, decrease the exponent by 1. Do the same thing for the other term. Exponent, multiplied in front, and decrease by 1. So 5 times 2 is 10, and 2 minus 1 is 1. Now to add the derivative of the second term, 7 times 10 is 70, and 7 minus 1 is 6. So we have 70x to the power of 6, and that's your answer. Now let's continue using the power rule on this third example. Here I'm going to involve brackets. So we'll have x squared minus 1 multiplied by x plus 3. First, we need to get rid of the brackets by multiplying across. Right, so we have x squared times x, which is x cubed, then x squared times 3, 3x squared, negative 1 times x, and negative 1 times 3 is negative 3. Okay, now we're going to find the derivative of this gx function. Notice the notation is the same as what we did for f of x. Now to apply the power rule, we are taking the exponent, multiplying it in front, decreasing the exponent by 1, and we do that for every single term in this expression. For the x, which has an exponent of 1, we are also taking that exponent, multiplying it in front, then decreasing that by 1. And for the constant minus 3, we have x to the power of 0. Let's see now what happens to these terms once we take the derivative. 3 multiplied in front, decreased by 1, is 3x squared, right? Then 2 multiplied with the 3 in front, decreased by 1, would be 6x to the power of invisible 1. And for negative x to the power of 1, we take that exponent of 1, multiply it in front, that gives us a negative 1, but the x to the power of 1 should become to the power of 0. Now whenever you have something to the power of 0, we know that that is just also equal to 1, so we don't have to write that at all. And the derivative of a constant, which in this case is negative 3, the derivative of any constant is always 0. So you don't have to write anything here. And this is the derivative of the function. Example number 4. The equation is y equal to 4 minus x divided by x squared. First, we're going to simplify this function. I want to break it up as 4 over x squared and then x over x squared. Now, these can be simplified. 4 over x squared can be written as 4 times x to the power of negative 2, and x over x squared can be written as x to the power of negative 1. Remember the exponent law that says if you have the same base, in this case x and x, and you're dividing by that same base, then you can take the top exponent and minus it from the bottom exponent. This gives us -1. Now, in order to take the derivative, we'll write the notation like this. The derivative of y with respect to x is dy over dx. So again, using the power rule, we'll take the exponent, multiply it in front, decrease that exponent by 1, and this gives us -2 times 4, which is 8, x to the power of -2 minus 1, which is -3. We're going to do the exact same thing to the other term. So multiply -1 with -1 to give us positive 1x, then minus -1 with -1 to give us -2. And this is the answer. Example number 5. Here I'm going to say find the derivative. So that's what the dx implies. It's an operator that tells us to find the derivative. So find the derivative of the expression the square root of x plus the cube root of x to the power of 4. Alright, now remember, you always want to be expressing the terms as some coefficient with x to the power of an exponent. And we don't really want to be dealing with these square roots. So how can we convert that to something that looks like this? So again, to refer back to one of our exponent laws, we know that the nth root of x to the power of m can be also expressed as x to the power of m over n, the inside exponent divided by the outside exponent. And that's how we write it. Now to use this in example number 5, we can rewrite the square root of x as x to the power of 1 over 2, with the inside exponent for the x being 1, and square root is the invisible 2. So 1 over 2. Now applying the same thing for the next expression, we have 4 over 3 as our exponent. And now we are ready to take the derivative. So the power rule says that we need to take this exponent, multiply it in front, decrease that exponent by 1, and do the same for the other term. Multiply the exponent in front and decrease it by 1. Okay, that leaves us with a half x to the power of, what's a half minus 1? That should be -1/2. Applying the same thing for the other term, 4 over 3 gets multiplied in front, and then if you decrease 4 over 3 by 1, you are left with 1 over 3. And that's our answer. Now for our final example, I've already pre-written the question, so let's just read through it. It says, find the derivative of dv over dr for v equal to 120 over r plus r cubed over 32. Now there's no further context given to this question, but we could assume v to be something like the volume. It could be the volume of a cylinder, or perhaps the volume of a cone, or maybe the combined shape of volume and a cone all in one. And perhaps r represents the radius of the cylinder or the cone in this context. So essentially what we have here is a formula for volume with respect to the radius of whatever shape we are dealing with. And we need to find the derivative of the volume with respect to the radius. So now in order to do that, we first need to simplify these expressions. Okay, we need to write them in a better form. They need to be in the form of a, which is the coefficient of x, or in this case r, to the power of some exponent n. And if we can get it in this form, with a coefficient, a base of r in this case, and raised to some exponent, then we can take the derivative, because we have the power rule to deal with things that look like this. So for our first term, we can rewrite that as 120 pi multiplied by r to the power of -1. The exponent was +1, but once you take this to the top, it becomes r to the power of -1. And for the next term, we can write that as 1 over 32 multiplied by r to the power of 3. Because r to the power of 3 is already in the numerator, we can simply separate it from the fraction 1 over 32. Now to find the derivative, dv over dr. We take the exponent negative 1, multiply it with our coefficient, decrease that by 1, and that gives us negative 120 pi times r to the power of negative 2. And for the second term, when doing the same thing, multiplying the exponent in front and decreasing the exponent by 1, we end up with 3 over 32 times r to the power of 2. And that's our answer.